We've learned that electrons can behave both as waves as well as particles. Well, we also learned that if light is, shining through two gaps, and these two gaps are rather small, interference patterns are created by the light where you would have a specific amount of light shining very much and creating a dark interference pattern, and a specific amount of light not creating any pattern at all, and creating a pattern but rather kind of brighter compared to the dark fringes during the slit experiments. However, we also learned that light can behave as a particle during the photoelectric effect. The same thing exists with electrons. Electrons can also get diffracted. If the gaps through which electrons are going through are very small, somewhere about 10 to the power of negative 12 meters, which is about a picometer, then electrons can also get diffracted. Now, how does this process happen? Imagine we have an electron. This electron is fired at a metal foil. Behind this metal foil, we put a screen to record what is happening. So basically, the electron fires itself at the metal foil. If we were to look at the screen after the process, we would see circles, concentric, and behaving and demonstrating diffraction patterns. If concentric circles are seen in such an experiment, then we can assume that the electron is producing diffraction patterns. The diffraction pattern that is created by the electrons proves that particles, matter, or things like electrons, can act like waves. And since they can act like waves, they have a wavelength. So they should have a wavelength. Now, if you wanted to calculate that wavelength that these particles have, we would have to use a famous equation that was created by a famous prince, Mr. de Broglie. De Broglie's equation basically states that if you wanted to find out the matter's wavelength, you can divide Planck's constant by the momentum of that object. Here in this equation, lambda is the matter's wavelength. Matter wavelength, where the unit of wavelength is meters. H is Planck's constant 6.63 times 10 to the power of negative 34. And P is the momentum of the object, which can be calculated by multiplying the mass of that particle or matter and the velocity of that particle. In most questions, usually the mass of the particle is the mass of an electron, and the mass of the electron is 9.1 times 10 to the power of negative 31 kilograms, whereas V is the velocity of that object, and usually it's like a simple percentage of the speed of light.